Equations of motion. Love them or hate them, they are part of our grade 10 syllabus and they are very important. You'll see them in grade 11 and grade 12. Well, good day, all our grade 10s. I hope that you find yourself well wherever you are. So this morning or today, we are going to be looking at equations of motion. So if you haven't subscribed, please just do the right thing. And let's get right into it, right? So firstly, we've got four laws of kinematics or equations of motion, right? And I am going to be talking about each of those symbols. So this is equation number 1. Usually we refer to this as equation 1, and this as equation 2, and this one as equation 3, and that as equation number 4. Right, now we're going to look at all of these equations, and first, let's talk about what each of those symbols stand for. So we're looking at VF there. So we usually call this our final velocity, and our final velocity is measured in meters per second. And we've got VI, which is the initial velocity. So this means that this would be the velocity right at the beginning of whatever scenario that you are looking at. And it is also measured in meters per second, right? And so we've got acceleration, which is, in this case, the rate of change in velocity, right? And it is measured in meters per second squared. We've got time, right? Or the change in time. And that's measured in seconds. Look at me saying meters. That's measured in seconds. So meaning, if your time is given in any other unit except seconds, we must convert it to seconds, right? And finally, we've got delta x, which is what we call our displacement. Of course, for those of you who are going to continue with physics, and I'm hoping all of you are, right? You are going to see this as well, becoming delta y, which means that we're looking at displacement vertically, right? Now, let's talk about what we're going to do when we are dealing with laws of kinematics. So each of those equations or formulae is actually unique, right? You'll see that in the first equation, in the first formula, right, you do not have delta x there, right? In the second formula, you'll notice that you do not have time there, right? Delta t. In the third one, you do not have final velocity. And in the last one, you don't have acceleration. Now, you will pick one of these formulae based on the information that you are given, right? And then you will obviously choose the equation that best fits whatever it is that you're looking for. Now, when we deal with this, the first thing that I'm going to ask you to do is highlight your information, right? So that's what you're going to do. So it is very important to highlight information and to be able to check the things that you need. Now, what are the things that you need to highlight, right? So highlight words such as, right? If I say something is moving from rest. Okay, so when we say from rest, that usually implies that its initial velocity is 0. Okay, so initial velocity is equal to 0, right? Remember, we used the symbol VI for initial velocity, but we also have words such as, in fact, that's not number 2. If I say something comes to a stop, okay? So if I say something stops, then what does that imply? It implies that our final velocity will be 0, right? So those are the kind of words that you're going to highlight. But I want you to also note, if I look at things like something that is moving at constant speed, right? So if they say constant speed, then I know that it means that my acceleration is equal to 0 meters per second squared, right? So note in this case, that is something that is crucially important because it forms part of, the information that you're going to fill in. Right, I'm going to go through this with you a little bit more. Right, number 2, what are you going to do? Write down all the information that you have. Now, you're going to choose a path, right? So choose a path. Now, what do I mean a path? So you're going to choose where you are going to start from and where you are going to end. Now, the picture that you are given may tell you something that is completely different, right? Let's say they say you've got a motorbike that starts from rest, accelerates for some time, and then afterwards moves at constant speed, right? So what does that mean? You've got 2 sets of motion. Firstly, when the bike was accelerating, so you can start from, well, my start is when it was at rest, and I end where it now stops accelerating, right? That is where it now moves at constant speed. That would be my end, right? So, or you can take from where it begins, right, to move at constant speed, and that would be your chosen path. Now, please, I want you to note, ladies and gents, once you stick to that path, you must fill in the relevant information for that path, right? So fill in the relevant information for the path. Okay, so that is important. Right, and the third thing, now note, choose the right equation. All right, now note that you do get marks. You are awarded marks for choosing the correct equation, right? Now, in this case, it means that you're going to choose the correct equation based on the information that you have there. Of course, in your information, if you don't have time and you're not looking for time, you're going to take the only equation without time. You'll see that as we continue. And then finally, just simply substitute. Now note, for those of you that are doing the CAPS curriculum, right, in particular DBE, please note that when you substitute, you actually substitute first before you actually start manipulating your equation, right, before you find the subject of the formula. Right, now ladies and gents, here's what I'd like for us to do. Let's choose some questions and let's get right into it. Let's start with our very first question. They say to us, a car accelerates from rest, okay? And you remember what I said to you? That you're going to have to learn to highlight things that are important. So the car accelerates from rest at 15 meters per second squared for 2 seconds, right? So that's very important. All right, now they say to us, and that's on a horizontal road, and they say define the term acceleration. Of course, we know that acceleration is the rate of change in velocity, right? Now let's get to the part where we apply equations of motion. They say to us, calculate the distance covered by the car. Now, let's just first try to see what information do we have. We are given initial velocity. And our initial velocity, remember, we said once we say from rest, it implies that our initial velocity is 0, right? And now, we don't have the final velocity. Our acceleration is given to us as 15 meters per second squared, right? So the car is moving faster and faster, and the time that is given is 2 seconds. Now note, we don't have displacement as well. So the question wanted the distance or the displacement covered. So we're looking for the distance. So note in this case, ladies and gents, that we want displacement or the distance that the car traveled, but we don't have final velocity. So we need to choose the only equation without final velocity. And which one is that? Remember, we said delta x vi delta t plus 1 over 2 a delta t squared, right? This one doesn't require a final velocity, so I'm going to use that because I'm looking for the displacement. Now let's substitute. I've written down the equation, right? That's the correct equation. And now I am going to substitute before I actually make the subject of the formula. In this case, I wouldn't really have to. It's already the subject of the formula, right? That is delta x. So my initial velocity is 0. The time is 2 seconds. That's half of the acceleration, 15 meters per second squared. You don't have to substitute your SI units. And of course, the time is 2. Please remember to square this one. That's often the mistake that I notice with many learners. Right, so let's see, what are we going to get? So that's going to be 2 squared, which is 4, times a half, that's 2, times 15, that gives us 30. So that will be 30 meters. That's the distance, right? And now they say to us, determine, okay, for 4.2.2, calculate the velocity of the car. That is, we are looking for the velocity of the car after the 2 seconds of accelerating. So it started from 0 here, right? We want the velocity over here after it has been accelerating for 2 seconds, right? And now, which equation can we use? We're looking for final velocity. We've got initial, we've got the acceleration, and we've got the time. And I'm sure you can see how that will actually have the first equation. Right, and again, what are we doing? We are just substituting. Initial velocity, that's 0. Our acceleration, that's 15. And our time is 2 seconds. Right, now when I look at that, my final velocity will also be 30 meters per second, right? And now, because the question said the velocity of the car, well, we were not told in what direction the car is headed, so we're going to just maintain in the original direction, right? Okay. Note that velocity is a vector, so we do need to state direction as well. Right, ladies and gents, let's get into another question that probably might be a little bit more involving, right? So that's what you do when it comes to equations of motion. Let's look at another one. Let's have a look at this question that we're given here. So they say to us, we've got a taxi that is traveling at a speed of 25 meters per second, right? So we note the taxi is traveling initially, right? And they say to us, when a traffic light 40 meters ahead changes to red, okay? Now, that 40 meters has got nothing to do with the taxi. It's just the distance away from the traffic light. So now we're going to have to apply ourselves just a little bit more. Of course, they say to us, define acceleration. We know what that is. We've just spoken about it. Now they say to us that driver takes 1 second to react, that is reaction time, before he slams on the brakes, right? The taxi then stops within 2 seconds. Now I want you to note, ladies and gents, here's our taxi traveling. So which means at this point, our initial velocity was 25 meters per second. But the driver delays to react. But remember, during that time that he fails to react, that 1 second, the taxi is still moving, right? So essentially, he's going to start applying brakes. Now, if you don't mind, let me call this A. Let me call this B. So from A to B, our taxi, for that 1 second, this is the reaction time. Okay, so this is the reaction time. our taxi was actually still moving, right, at 25 meters per second. And then what happens? He starts applying the brakes from B, and we want to know, is he going to be able to stop, at the traffic light? But we'll get to that in a while, right? So we know that it takes him 2 seconds to stop. So which means from this point till whatever point where he stops is 2 seconds. And secondly, what we do note there is that they said before he stops. So notice what is important here. The velocity at this point is 0 meters per second. Right, now let's quickly answer the question. Now they ask us the question, is the velocity and acceleration of the the acceleration of the braking taxi in the same direction as it moves towards the traffic light? Okay, so I'm assuming that they're asking about this point when he now starts braking. Now notice that the velocity is still in the positive direction. Even though the car is slowing down, right, its velocity is still in the positive direction. However, notice that when we slow down, and I did say this when I introduced this section, when we slow down, its acceleration is going to be acceleration in the opposite direction. Some call it deceleration, but we don't really like that word, right? So this is going to be negative acceleration, okay? That we have for this question. Now let's answer the rest of the questions. So to answer that question, is the velocity and acceleration of the car in the same direction? The answer is no. And they say give a reason, right? They said give a reason for that answer. Let's write that 3 nicely. Okay, we know that as the car slows down, okay, the acceleration acts in the opposite direction, right? In the opposite direction. Right, I'll say opposite direction of its motion. Right, now I am going to go to the next. Now we're looking at the calculations. They say calculate the distance the taxi travels during the reaction time. So we want to know, during that 1 second, what is the distance that the taxi will move? And by the way, please note that it will maintain a constant speed during that that travel time. So I know my velocity is constant here. That is, it's at 25 meters per second, right? I know that it maintains this for for 1 second, right? So now that means that our acceleration is 0. Remember, for constant speed, the acceleration is 0. Okay? So what we're going to do now is just look for the distance between those two. Right, so I'm going to say, well, delta x, that's 1/2 times vi plus vf times delta t. Now note, in this case we said, because it's moving at constant speed, it means that initial and final velocity are exactly the same, right? And I want you guys to also note, we could have used this equation. Now note, if I said delta x is vi delta t plus 1/2a delta t squared, notice that because the acceleration is 0, A is 0. So this means that this entire term falls off. Now, let's substitute. Our initial velocity and final are both 25. And the time is 1 second. Or if you wanted to use this equation, you could have said initial is 25 times 1 plus half times 0 times 1 squared. And you'll see that that other term actually just falls off. And what are we left with? That's 25 meters, which would be the same as well on this side, 25 meters. So which means during the reaction time, the car actually traveled 25 meters. Now meaning, how much distance, right? How far would the traffic light be from it? If I've traveled 25 meters from A to B, then it means from B to C, or rather, from B to C where the traffic light is. In this case, that would be 40 minus 25. That should give us 15 meters, right? So that would be the distance that we have. Now let's calculate. They say, will the taxi stop at the traffic light? Show all calculations. So what I'm going to do, ladies and gents, is I'm going to measure the distance that the taxi will actually travel during the 2 seconds. If I find that that distance is greater than 15, it means the driver was not able to stop in time. Remember, that's the distance from the traffic light, right? That's how far the taxi is, right? So it is 15 meters away from the traffic light. If the distance that I calculate is greater than 15, then it means that the driver was not able to stop at the traffic light. But if the distance is less than 15 or 15, in this case, it means that he was able to stop. Right, so let's do that. So we know our initial velocity. Now, please, I want you to note, ladies and gents, our initial velocity is 25. Our final velocity is 0. Remember that we said he stopped, right? And this happened for 2 seconds. So let's calculate then. All right, so what we don't have there is acceleration. So I can say, well, delta x is 1 over 2 vi plus vf delta t. Our displacement in this case is what we're trying to find. Our initial velocity is 25. Our final velocity is 0. And the time that it took was 2 seconds. So in this case, if I calculate, I get a distance of 25 meters. That's only when the car is able to actually stop. So let's answer the question. Will the taxi stop at the traffic light? The answer is no. But why is that? Okay, because the distance that it travels during that time when the driver is braking, okay, the braking distance is equal to 25, which is greater than the distance to the traffic light. Right, I hope that made sense, ladies and gents. All right, and really that is how we come to the end of this question. Right, I'm going to be doing some more questions on equations of motion. Please have a look at them. And as I said, guys, if you're struggling with maths or science, you're more than welcome to get in touch with us. We've got online classes that are available, but we also have, other programs like our camp, which is coming up. Okay, please have a look at the link that is on the link tree. You can visit us on our website, which is www.mlungisinkosi.co.za. Ladies and gents, I hope that you have understood, and it's been a pleasure being with you. I'll see you guys again next time. Shap shap.